Hello students, so in this video I'm going to explain you about the Maclaurin theorem. So in order to find the Maclaurin theorem, we have to learn about the Taylor's theorem. So in the previous video I have already explained about the Taylor's theorem in Lagrange form. So let us go through about the Taylor's theorem. So we have already proved in Taylor's theorem that f of a plus h is equal to fa plus h f dash a plus h squared by 2 factorial f double dash a plus dot 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 plus h to the power n minus 1 by n minus 1 factorial f to the power n minus 1 a plus h to the power n by n factorial f n a plus theta h where 0 is less than theta is less than 1. So this is nothing but the Taylor's theorem. So we are going to derive about the Maclaurin theorem. So in case of Maclaurin theorem, in place of a you put as 0 and in place of h you take as x. So we'll try to put a equal to 0 and h equal to x in Taylor's theorem, where 0 is less than theta is less than 1. So if I put here like this, so if I put here in place, say if I put here a is 0 and h I put as x everywhere in the same way, so I'll get somewhat like this. So we get here f of 0 plus x, which is equal to f of 0 plus h plus x f dash 0 plus x squared by 2 factorial f double dash 0 plus x to the power n minus 1 by n minus 1 factorial f of n minus 1 0 plus x to the power n by n factorial f of n 0 plus theta x, where 0 is less than theta is less than 1. So we get here f of x equal to f of 0 plus x f dash 0 plus x squared by 2 factorial f double dash 0 plus so on plus x to the power n minus 1 by n minus 1 factorial f of n minus 1 0 plus x to the power n by n factorial fn theta x, where 0 is less than theta is less than 1. So this equation is nothing but the Maclaurin equation. Okay, this equation is nothing but the Maclaurin equation. Now I'm taking some remarks here. So we have Taylor's theorem remainder in Lagrange form. So when we look the Taylor's theorem here, the last term of the Taylor's theorem is nothing but this. So this is called the remainder of Taylor's theorem in Lagrange form. So we are writing the Taylor's remainder in Lagrange form is nothing but denoted by Rn, which is equal to Hn by n factorial Fa plus theta h. So this is the Taylor's remainder in Lagrange form. In the same way, we also find the Maclaurin remainder in Lagrange form. So if you look the last term of the Maclaurin theorem here, we can see that this is nothing but xn by n factorial fn theta x. So this is the remainder of the Maclaurin theorem in Lagrange form. So the remainder of the Maclaurin theorem in Lagrange form is nothing but Rn equal to xn by n factorial fn theta x. So I'm doing one question here. So apply Maclaurin theorem to the function. So we are taking the function fx equal to 1 plus x to the power 4. To deduce that, we have to reduce to 1 plus x to the power 4 equal to 1 plus 4x plus 6x squared plus 4x cubed plus x to the power 4. So for doing this, let us take this as fx. So I take fx equal to 1 plus x to the power 4. So we'll differentiate this function. So if I differentiate here, we get here 4 1 plus x to the power 4 minus 1, that is nothing but 3. And I'll try to differentiate the inside one. We get 1 plus 0, so I'm not writing that. That is nothing but 1 plus 0 is 1. So we get the differentiation to be this. Then again you differentiate this, so we get here 3 will come down, so 1 plus x to the power square. So we get 4 into 3 is nothing but 12, 1 plus x square. So again you differentiate this, so this 2 will come down, so 12 into 2, 1 plus x to the power 2 minus 1, that is nothing but 1. So we get here 2 into 12 is 24, 1 plus x. So I'll try to differentiate again this, so we get here 24 is a constant, the differentiation of 1 is 0, and differentiation of x differentiation of x is 1. So we get 1 we get here it should be 0 plus 1, so we get here 0 plus 1. So 0 plus 1 is nothing but it is equal to 24. So 24 into 1 we get 24. So by Maclaurin theorem we have here, we'll take the Maclaurin theorem. So by Maclaurin's theorem we have fx equal to, you take here f of 0 plus x f dash 0 plus x. This is the Maclaurin theorem for 4 terms. Okay, so f of x equal to f of 0 plus x f dash 0 plus x squared by 2 factor f double dash 0 plus x cubed by 3 factor f double dash 0 plus x to the power 4 by 4 factor f to the power 4 theta x. Okay, theta x where 0 is less than theta is less than 1. So f of x is nothing but 1 plus x to the power 4. So we put that, and f of 0 means in place of x, here we have find f of x already. So in place of x we put 0. So we get 1 plus 0 to the power 4. Then plus x, so x f dash 0. So here we have, this is our f dash 0, you put x 0. So we get 4, 1 plus 0 to the power 3 plus x squared by 2 factorial f double dash 0, we got this. So in place of x you put 0, so 12 plus 12 into 1 plus 0 whole thing square plus, then we have x cubed by 3 factorial. So we have here x cubed by 3 factorial, f triple dash is this. So in place of x you substitute 0, so we get 24, 1 plus 0 plus, then x to the power 4 by 4 factorial, f4 x theta x. So in place of x you substitute theta x, but there is no x, so no need to do anything, it will be 24. So we'll try to expand. This one will get 1 plus 0 is 1, so 1 to the power 4 is 1. So here also same, I get 1 here, so 4 into x is 4x. So 2 factorial is 2, so 2 and 12 will be cancelled, we get 6. So this is 6 x squared. We get next line plus, here if we can 3 factorial is nothing but 2 into 3 into 2 into 3, so that is 6 and 24. If I cancel, I get 6 4 just 24, so we get here 4. And this 4 factorial is 2 into 3 into 4, so we'll try to cancel this. So we get 2 into 3 is 6 4 is 24, so 24 and 24 will be cancelled. So we are doing the cancellation in that way. So after cancelling, we'll get the answer to be 1 plus 4x plus 6x squared plus 4x cubed plus x to the power 4. So that is nothing but what we want to prove, so we have proved it. So in that way we are going to do some more problems. So for this video I'm stopping here, so thank you.